right. Hello, everybody. I'm Mike Human, and this is the G2M Research Multi-Vendor Webinar on NVMe over TCP. Just quick walk through the agenda. So the first thing we'll do is I'll talk a little bit about the topic and provide some ground rules on it. Then we'll go through each of the sponsoring vendors. We have 4 of them today, and I'll introduce them shortly. Each of them will talk for about 5 minutes. Then we'll go through 3 key questions and 3 audience surveys. The audience surveys, we want you guys to participate. You can do that through the Zoom client. After that, we'll have Q&A and we'll do a wrap-up. Quick note on the Q&A, if you put questions in, please do so by putting them in the Q&A window on Zoom. We'll answer all those at the end. And then what we'll do is at the end of this, in about 2 days, we'll send out a link to the recording and to the slides to everyone that's registered. So all of you will get that in about 2 days. And with that, let's go ahead and get started. So joining us today, we have 4 panelists. The first one is Rob Davis. Rob is VP of Storage Technologies at Mellanox. We also have Tom Spencer, who's Senior Director of Product Marketing at SolarFlare. We have Elliot Rosen, who's Product Marketing Director at Broadcom. Nishant Lodha, who's Senior Product Marketing Manager at Marvell. So what is NVMe over TCP? So it's a new binding for NVMe over Fabric that was approved by NVMe.org late last year, about the December timeframe, if memory serves. It's basically a way to take NVMe over Fabric or NVMe commands and do them remotely, but this time using TCP IP sockets as the communications protocol. Just as you'd think, NVMe commands are actually sent over standard sockets. Each queue pair is mapped to a TCP connection, and the TCP provides reliable transport for the NVMe queuing model. NVMe over TCP also provides an alternative transport to NVMe over Rocky and NVMe over iWarp for Ethernet, and to NVMe over Fiber Channel, NVMe over InfiniBand. So now it's basically one of 5 different protocols we have that you can access NVMe commands remotely. Some of the characteristics about it, and I'm taking this from different discussions that have happened in NVMe.org, and our panelists will talk more about these. NVMe over TCP can run on existing TCP IP networks. It doesn't require any special switches or any special protocols or flow control. NVMe over TCP is compatible with existing Ethernet management applications. In fact, that was one of the big reasons they actually started driving the idea for it. Some of the disadvantages that have been reported. So it has higher latency than NVMe over Rocky, which is today the fastest of the Ethernet-based protocols from a latency perspective. The other one, and this is true of anything other than, NVMe over Fiber Channel, it's a converged SAN LAN. In other words, there's not a separate dedicated network just for SAN traffic. So that's a trade-off that all people that are architecting a solution would have to make if they want to use NVMe over TCP or NVMe over Rocky or NVMe over InfiniBand. So some of the questions we'll go through in this webinar. The first one is, what are the use cases for NVMe over TCP, and what strengths does it bring to these use cases vis-a-vis the other NVMe over Fabric protocols? Secondly, how important are those advantages and disadvantages for its use case in real-world deployment scenarios? And then finally, to what extent will it replace the other NVMe over Fabric Ethernet protocols, and how long will it take to do so? Or conversely, which use cases will it not replace them for? So with that, I'm going to introduce Rob Davis. As I said, Rob is he is the VP of Storage Technology at Mellanox. He's been in the storage world for quite some time. And Mellanox, obviously one of the big companies that have been driving NVMe over Fabric. So Rob, go ahead and take over.
Sorry about that. First of all, I want to start off by saying that Mellanox supports NVMe over TCP across all of our Ethernet products. This includes our ConnectX NICs and our Bluefield SoCs. We see NVMe over TCP and NVMe over Rocky as complementary solutions, And in fact, our devices can support both at the same time. We do see differences in performance, most notably in the latency, which of course relates to the IOPS, and CPU utilization. And with the latency, our DMA is not only lower, but also much more consistent and predictable. Keep in mind, though, that the Linux open source NVMe over TCP software stack has only been released, as Mike said, for a couple of months. Our engineers, as well as others across the industry, are continuing to improve it all the time, and we expect the performance to continue to improve. And as the #1 vendor for 25 gig and greater Ethernet NICs with around 70% market share, Mellanox has a very vested interest to make sure that it does. We see many use cases for NVMe over TCP that are not performance dependent. One of our OEM customers, Pavilion, has shown the value of NVMe over TCP in connecting to stranded servers. A stranded server is usually an older machine in the data center with a can't live without application that needs to be connected to the storage network but can't be moved to a more modern machine. You can read all about this in detail in a Register online article by following this URL. But basically, the Pavilion customer had a mix of these older machines without RDMA NICs and newer models that had them. Their all-flash array supported NVMe over fabrics with both TCP and Rocky using our embedded ConnectX NICs. The NVMe Rocky had twice the performance of the NVMe over TCP, but the NVMe over TCP performance was still twice as good as the iSCSI alternative. And all the customer servers, all of the Pavilion's customer servers were now able to be part of the NVMe over storage fabric. So we think this is a very good use for NVMe over TCP. Another use case is distance connectivity. For the best disaster recovery applications and high availability storage solutions, multiple data centers need to synchronize their data. And TCP, of course, has been used to move data around the world, with the internet and everything else before that for at least 30 years. So it's a very proven protocol for this kind of application. In fact, we actually tested this with straight, very early open source off the NVMe.org website or the GitHub with NVMe over TCP between our offices in California and Israel across the internet with no modifications, just basically right out of the box. The final example I'm going to show is using NVMe over TCP for out-of-band management. Often data centers have low-speed management networks totally independent of the main network. This is for management tasks like diagnostics, firmware updates, devices not responding that need to be reset, etc. This network usually connects to BMCs or baseboard management controllers in the equipment, not the main CPU. These baseboard managers are very small, low-powered CPUs with very simple operating systems. But of course, they support TCP, and so this allows the NVMe management protocol called NVMe-MI to use these independent control path networks, these out-of-band networks, to get connectivity. All right, so those are the use cases, just a few of the use cases. The other presenters will have more. Now I'm going to sort of finish off with a quick look in more detail at the performance differences we see with NVMe over TCP and Rocky. These tests were all run, at least at the time of this test, with the latest software stacks. The left chart shows the difference between NVMe TCP and Rocky IOPS, and the right chart is the CPU utilization. Green and red lines are TCP reads and writes, and blue and orange are Rocky. The platforms for these tests are identical. our NVMe over Fabric protocol offload feature was not used. So there was nothing but straight software stacks here. This is all open source from NVMe.org TCP and the Rocky stacks. And again, it's all identical, run on identical hardware as well. So you can see as the load on the software stack, which is the number of jobs on the y-axis or the x-axis here, this basically is queue pairs. As you increase that, the difference in performance becomes greater. But you need to remember that RDMA's design focus was performance and TCP's was general purpose connectivity. So you'd expect to see a performance difference there. On this chart, I'm showing that the consistency of the performance is also different. So for latency tests, what we did was we added the local SSD, which is in the purple, which is the purple for reads and the brown for writes. And notice for both reads and writes that the NVMe RDMA latency is not only less than TCP, but it tracks the local NVMe SSD latency quite closely, which means that even across the network, it's tracking to the same latency that the local NVMe SSD does. But the TCP/IP latency does not. It has much greater what's called tail latency. The y-axis on this chart is kind of a hard chart to understand, but the y-axis on this chart shows how often the measured latency is at the x-axis measurement point. So, for example, if you look at the 0.6 on the y-axis, it means everything below that, 60% of the time, everything below that was at that latency. So NVMe over Fabrics with Rocky provides not only lower, but much more predictable latency. And this is not surprising because RDMA was designed to be used in supercomputers where that is a must. But predictable latency is also important even outside of supercomputers because many of today's applications are not tolerant of inconsistent latency. Data center network architectures have changed to accommodate much more east-west traffic over the last few years. And this is to support more interactive requests from the users. For example, a search request for a topic is no longer just looking through a database and responding. The data center is also trying to figure out first who you are, where you are located, what your economic bracket you're in, and what else you might want to see. You know, that using that, they try to figure out what else you might want to see, or more likely, what else you might want to buy. And it's very important that the extra information is shown to you before, you know, you click on to something else, because if it doesn't happen, they don't get paid, right? So this is very important to, you know, the new model in a lot of data centers, just for this particular application. And this is just one application in this category where persistent latency is important. This URL actually points to an article which details the changes in data centers driven by latency-sensitive applications. So to summarize here, Mellanox is 100% behind NVMe over TCP. Some of our customers are already using it. We think together with NVMe over Rocky and NVMe over IB, InfiniBand, it only increases the capabilities and the success of NVMe over Fabrics in the market. With that, I'm going to turn it back over to Mike.
Thank you, Rob. That was a great discussion. Let's see. Next, we have Tom Spencer. Tom, I'm going to give you remote control so you can run the slides. Tom is the Senior Director of Product Marketing from SolarFlare. And Tom, go ahead and take it over.
I'm trying to, oh, there it goes. Okay. So I basically put together a presentation to talk about why using TCP. The only performance benchmark that I have is this one here. So SolarFlare, for those of you that are not familiar, is a company that provides Ethernet connectivity solutions, but what we're known for is a TCP and UDP stack that we've developed over the last 14 years that runs in user space. Today, 90+% of all electronic trading worldwide is done using our adapter cards, and they use that stack. So we obviously saw an opportunity 2 years ago, and we got on board with TCP as a transport in the NVM Express consortium. This first slide that you're looking at, we talk about performance. So I have a different set of data on the performance side. We have two solutions at SolarFlare. One is a kernel mode solution, which is what everybody in the consortium currently has. That means it's a Linux plugin, it's a kernel-based driver, and it runs on anybody's NIC, basically. And so we have different benchmarks that show our kernel performance, and we actually ran our driver on competitors' NICs, some that are on this call, as well as on compared it against Rocky. And our findings for both IOPS and latency is that we're within 3 to 6% performance on both those metrics with transmit and receive traffic running our kernel driver. So I call that single digit margin between us and the RDMA technology. But what the slide you're looking at here is taking the technology that we use in electronic trading and applying it to a target mode solution. And what we did is we took the Intel Optane 3D Crosspoint storage device, which has a direct attached storage latency of 10 microseconds, which you can see in that bottom bar that runs across the page. And then we plugged in a network driver, a standard kernel network driver, and ran that same storage unit over the network and came out with about 37, 38 microseconds. We then turned on SPDK, which is a way to go from user space directly to the SSDs. And then we ran our acceleration technology on top of SPDK. And in doing that, we came in at around 17 microseconds compared to a 10 microsecond on a 3D Crosspoint. So this is illustrative of the fact that TCP can be performant in the network. We have two ways of approaching it: the kernel mode, which is within single digit percent of our competitors, and then we have this kernel bypass technology, which is fully compliant with the TCP spec, can interoperate with any host from any other NIC supplier. And so we have both options. So if you check us out at SolarFlare, you can see both options on our website. Second reason is ease of deployment. So although there are a lot of switches and endpoints that have been installed into data centers around the world, those that are actually running the Rocky solution today, we see that as less than 2% of all installed base. It could be a little bit higher with some of the hyperscale infrastructures, namely Microsoft. But the feedback that we're getting from many customers is they're looking for performant TCP so they can use this across the whole data center, and that includes legacy infrastructure. Runs to this point, runs on legacy networks. So when you're running TCP, you can actually interoperate with any endpoint and any switch. So we don't have to have a complete forklift upgrade of the infrastructure. You can take NICs that are out there today, you can take switches that are out there today and just use a Linux plugin, and you'll be able to run TCP-based storage over that infrastructure. The other thing about TCP, it's everywhere. It's ubiquitous. Everybody's got it. Everybody understands it. There's no special setups. There's no manual deployments, no manual tuning. It scales. It is not as performant as Rocky or perhaps iWarp. I haven't seen any benchmark data on iWarp. However, the question is it good enough? And then there has been some concerns in the past about whether TCP has congestion issues, and many of those issues of the past have been addressed. So whether those issues existed in the past or not, now we don't see that as a blocking point. If you look at the list of contributors to the TCP spec in the consortium, there's some big name players that are in there. A lot of the hyperscalers are moving towards the TCP. We actually have customers, most of them are looking for disaggregated storage. They see that SSDs with their low latency and the availability now of TCP gives them the ability to set this up in any infrastructure. So we've got telco customers, we have tier 1 and tier 2 cloud customers, and we even have enterprise customers that are all looking at this solution. So a lot of POCs are in flight. The spec's fairly new, but we're seeing a lot of progress with it. So 5 reasons to use NVMe over TCP: performance. We claim that we're within single-digit % of Rocky today with our kernel driver, and much faster with our kernel bypass. Ease of deployment, runs on legacy networks, it's ubiquitous technology, and congestion issues of the past are not a major concern anymore. That's all I have.
Thanks, Tom. All right. Let's go ahead and I think, Tom, you have to give me back control of the screen now.
Okay, let me figure out how to do that. Give up the remote control.
There we go. All right. Next is Elliot Rosen. Elliot is Director of Product Marketing at Broadcom. Elliot, let me give you control here. And you should be live.
So first, I just wanted to point out that from Broadcom's perspective, we're just excited about the opportunity that Fabrics brings. We offer solutions for essentially all of the different protocols, from Ethernet, which is the group compute connectivity that I represent, to Fiber Channel, which is represented by a few other divisions within our corporation. And so the fact that TCP provides an ability to extend that market capability is an exciting thing to us. So one of the things I wanted to do here is talk a little bit about what we perceive some of the benefits and potentially what have been seen as disadvantages of TCP versus Rocky in the market. Talk a little bit about how we're approaching that market and some of the products that we have. So just to echo, I think some of the previous folks who were talking about the advantages and disadvantages, one of the big benefits for TCP is its ubiquity in the market and in every network. The other thing about that is obviously it's been around for a long time, and then all the existing infrastructure from a software perspective, hardware perspective is well known. Congestion control, which has been one of the topics on the Rocky side, is something that's been well proven with TCP. Different types of implementations that have been done in the past, like BIC and Cubic and New Reno and BBR, those are all well proven and established. The other thing is that it's very simple to implement, runs over existing lossy networks, scalability from both local, close to across large geographic areas is well proven. And then the other thing too that's also important is that it really removes the requirement to configure the switches and parts of the network. So it basically leverages all the existing network configurations, which especially in the cloud space is extremely important, because typically when you're implementing storage technologies, trying to go to the network guys to make some modifications to the network configurations is challenging. In terms of some of the perceived disadvantages versus Rocky, I think this was talked to by, I believe, Rob, on longer latencies. So we also agree with that. That's one of the challenges. We've been doing a lot of work internally on long tail latencies, both with Rocky and TCP. We've done some work with Demartech on some analysis there. One of the things that we're seeing with some of the work we're doing with some of our customers and internally is that some of that, and especially on the tail latency side, can be mitigated with some software algorithm modifications. So multiple TC paths, backoff sending, et cetera. So there are some capabilities there to help mitigate that. The other bullet that I have here is on performance. So in kernel mode, it's typically more CPU bound. than you would have with Rocky. And yes, we see that there are some performance differences there, but we're also seeing with some of the development we're doing in user space and what some of our customers are doing, that user space does provide a much better performance compared to kernel. And so again, I echo one of the sentiments I think was Tom before me, that it really depends on what the customer is trying to do and implement, and is the performance good enough given the ease of deployment. So in terms of Broadcom's perspective, again, we support both Rocky and TCP/IP across all of our performance NICs and our Stingray-based SmartNIC devices. We actually were able to demonstrate simultaneous operation of TCP and Rocky at Flash Memory Summit last August. We see a great opportunity in the SmartNIC side of things, where you're actually offloading some of the storage services. And again, whether you're transporting over Rocky or TCP/IP, it provides a great value to the host systems by providing CPU utilization back to the systems. And whether it's a hyperscaler who generates revenue off of that, or it's an application server that can provide more performance back to the server, we see that as an important benefit. And then in terms of both fabric-based JBOFs, or what we call FBOFs, or scale-out architectures, having support for both Rocky and TCP/IP on the target side, we see as extremely important. So a little bit more about Stingray. So Stingray is in full production. We have the highest performance SmartNIC in the market today. We are working with a number of different operators on enabling SDS type of environments with an open programming model on A72s. We have hardware acceleration for a number of storage offloads like RAID, dedupe, and security. Again, as I mentioned before, we support both Rocky V2 and TCP. We have production adapters at both 50 gig and 100 gig today. And we are actively working and promoting, again, both the Rocky and TCP protocols. And just to summarize, so Broadcom has a number of end-to-end solutions today, from performance NICs from 50 gig to 200 gig, and again, our SoCs.
Yep, you got it. Thank you very much, Elliot. Last in our discussion is Nishant Lodha. Nishant is the Senior Product Marketing Manager from Marvell. Let me pass you the remote control, Nishant. And you should be good to go.
Thank you, Mike, and thanks to Tom, Rob, Elliot for providing a beautiful perspective on NVMe over TCP. And I'll add to some of what you guys said as soon as the slide flips through. Okay, so when it comes to Marvell and Marvell solutions for NVMe over fabrics, there is, to my knowledge, no other provider that provides a more complete NVMe over fabrics solution to customers. When it comes to either broad spectrum Ethernet or fiber channel connectivity, from 16 gig, 32 gig, and higher speeds of fiber channel, doing FC NVMe or up to 100 gigabit Ethernet NICs, Marvell provides both Ethernet and fiber channel solutions to scale out NVMe all across the data center. Not just that, when you kind of double click on the Ethernet piece, Marvell Ethernet NICs, which are branded under the FastLink umbrella, support RDMA, and not just a single type of RDMA, but support the universal RDMA, which is basically all the three types of RDMA that you can use concurrently, which is Rocky, the routable Rocky V2, as well as iWarp. So customers have the ultimate choice in the type of RDMA protocols they want to use. This discussion is about NVMe over TCP, and kind of the special thing within Marvell Ethernet technology that fully offloads the NVMe over TCP stack is that within our NICs, there is an embedded TCP offload engine that can help offload NVMe over TCP. And I'm going to walk you through how that works and what its advantages are Fiber channel, QLogic, now part of Marvell, is a leader in fiber channel connectivity, and we see FCNVMe also as a very dominant protocol for scaling out NVMe for all-flash arrays out in the future. It's not just about providing hardware and Ethernet NICs and fiber channel HBAs. It's about end-to-end solutions. We work with server vendors, storage vendors, hyperconverged infrastructure vendors, and integrate our target mode solutions, not just on the kernel side, but also on the user space with SPDK, leveraging our years and years of storage and networking experience to deliver a complete end-to-end solution. For end customers, right, it's not a button that they flip on to migrate from legacy storage protocols to NVMe over Fabrics, and the migration path needs to be planned out carefully, and hence we pay careful attention to make sure that the customer's legacy protocols, as well as the emerging protocols like NVMe over Fabrics, can run concurrently, and hence Marvell Ethernet as well as fiber channel solutions continue to do an entire range of concurrent storage protocols when it comes to either iSCSI, FCOE, fiber channel, all of them kind of migrating towards NVMe over Fabrics and FCNVMe. So I know perhaps NVMe over RDMA, I would say, is, I wouldn't use the most popular, but at least the most talked about NVMe over Fabric solution. But I want you to take this audience through a little bit more detail, kind of to understand what is the intricacies of NVMe over RDMA solution. First of all, it's important to understand that NVMe or RDMA has, or RDMA as a protocol has a bunch of challenges, and the entire ecosystem kind of together, all the vendors here as well as other industry organizations are working to solve some of these challenges. But in practical situations, many of these challenges remain. First of all, RDMA, especially Rocky, is prone to congestion, and there are no simple, easy, press this button solutions to solve this congestion problem. There are protocols like DCQCN, data center quantized congestion notification, and advancements in those areas that can help elevate some of these congestion challenges. But applying these policies and applying DCQCN to a network is not that simple. Right? It's not precise. As workloads change, you may need to change your settings again. And if you have like PhDs running your networks, perhaps Rocky V2 is a great choice, and you can manage and deliver a lossless network. But most of the customers I talk to don't have PhDs running their networks, and they have smart IT networking people, definitely. And hence, managing congestion in that kind of network could be challenging. Also, as Tom said, right, there isn't a whole lot of RDMA expertise out there, just from an install-based perspective, as well as consumption of the technology has not really happened. Also, it has the same point kind of that Rob was making earlier in his talk about a customer that Pavilion Data had. There are customers who have legacy servers, legacy applications, and which have a long shelf life. And these servers do not have RDMA-enabled NICs, right? Tom Spencer's own statistic with about 2% or more or less servers having RDMA capability. So if you were designing NVMe over RDMA storage array or appliance, we need to find people or servers who would connect to it with less than 2% using Tom's own statistics. You will create islands within the data center where only a smaller set of servers which have newer modern RDMA-enabled NICs can talk to this brand new honking expensive NVMe over Fabrics array. And also within the RDMA ecosystem, although Marvell supports both Rocky V2, Rocky as well as IVOR, but there are CAMs. Not all the NICs out there support all the different RDMA protocols. And hence it is important to understand that for all the benefits that NVMe over RDMA has specific to low latency, there are possibly some skill set as well as infrastructure changes that could potentially be required that all of you guys should be well aware of. What we did was, like I talked about, the Marvell FastLink Ethernet NICs, they have an embedded TCP offload engine. So we collaborated at last year Flash Memory Summit with Toshiba memories, software-defined storage called Kumoscale, to deliver and demonstrate at the Flash Memory Summit in August last year, offloaded NVMe over TCP accelerated solution. And we showed some of the metrics there that I'll kind of walk you through in the next slide. But importantly, for all of us that worked on this project, Flash Memory Summit recognized this demonstration of NVMe over TCP offloaded as the most innovative technology at Flash Memory Summit, and we were awarded that. I want to take a little bit of kind of a little bit more detail on how does the offloaded NVMe over TCP stack works and what is its potential value. So if I kind of build this up as to how stack looks like for NVMe over TCP. So life begins with I/O from an application. Take an example of, let's say, FIO, if that you are running goes through a file system, block multi-queue. The NVMe layer is the one that manages the submission and completion queues. Then comes the NVMe over Fabrics layer that kind of encapsulates the submission queue into a capsule, which may or may not have in-capsule data, typically up to 8K. Then comes the NVMe over TCP layer, and that's where NVMe over TCP differs slightly from NVMe over Rocky, where you have a concept of a PDU, and where the NVMe over Fabrics capsule is encapsulated into a PDU, and a PDU header is attached to that. This PDU is then kind of fragmented into different TCP payloads, which is again then sent over the wire by the NIC in terms of Ethernet payloads. And this is how a typical stack looks like, where all of this work that you're seeing here is done by the host processor and x86 or ARM processor doing all of this I/O. If you look, double click into what some of the functions that are happening within the NVMe over Fabrics and the TCP/IP stack, there's a bunch of work that a server processor would need to do to make sure that NVMe over TCP payloads eventually hit out on the wire, whether it is mapping the queue pairs to a TCP connection, doing header and data digest, constructing the PDU headers, all the segmentation and header processing that comes with the TCP/IP and the Ethernet stack up there. All of this consumes CPU cycles. All of this comes in the way of accelerated performance with NVMe over TCP. What Marvell brings to the table here is offloaded NVMe over TCP engine in their FastLink NIC. So all of, whether it's starting from creating the PDU to segmentation, header processing, calculating the digest, checksums, all of that is offloaded to the Marvell NIC. And what that delivers you is the following, right? It delivers you accelerated performance. You get better latencies, you get higher IOPS, and more importantly, you free up your server CPU to run applications that create business value for you. And so you don't spend your precious processor cycles on just transacting NVMe over TCP data. So here is a quick look at some performance metrics done internally at Marvell. I do want to say, like, if some of you guys are paying attention to Rob's slides, he talked about some performance differences between RDMA and TCP, but most of those metrics, as best as I could catch from the slides, were all 512 byte data. And to my understanding, storage traffic is not 512 bytes, and storage traffic is more 8 kilobytes, 16 kilobytes, and higher. So here is kind of a performance that indicates how NVMe over Rocky compares with software TCP and how that compares with hardware TCP. And what I mean here by software TCP is that the initiator as well as the target both are using a server x86 or ARM cores to do NVMe over TCP. Well, in the case of NVMe over hardware TCP, the target is offloaded. And in some of these measurements, I did not have offload on both sides of the equation. So the green bars that you see here, which is offloaded NVMe over Fabrics TCP, are supposed to go further down when the initiator is also offloaded, which is generally the case for NVMe over Rocky. Having said that, one thing that I would want you all guys to walk away with, NVMe over TCP, even if it is hardware offloaded, is generally in many situations not going to beat the performance of NVMe over Rocky. If you have applications that are looking for the last ounce of latency and are very latency sensitive. You have the energy and the network to deliver a lossless network. You have the potential to manage congestion in your network. Perhaps Rocky is a great choice. If you like simplicity, if you have applications that can live with a little bit higher latency, NVMe over TCP is a great choice. As you can see, software TCP does have much higher latency than offloaded TCP. But when it comes to multi-threaded performance, when you're talking about more top-line IOPS, we see in our own measurements that hardware TCP as well as Rocky V2 provides similar top-of-the-line millions of IOPS performance, while software TCP is bogged down primarily because we were running out of CPU horsepower because software TCP utilizes a bunch of x86 cores. So what I want to here to kind of walk the audience off is that this is 8 kilobyte performance. This is real world performance. And if you're looking for the lowest latency, perhaps Rocky V2 is a great choice. But if you can adjust just a slightly higher latency, but with simplicity, hardware offloaded TCP is a great choice. It saves you CPU cycles, run your applications that deliver business value to you. With that, I want to just make just one comment here, but end of the day, I would ask the audience not to make their own decisions about what fabrics they want only based on performance, right? It is about what things you as a company who wants to deploy NVMe or fabrics is comfortable with. So maybe you have a bunch of fiber channel equipment. Maybe you have fiber channel expertise. You trust fiber channel as a protocol. There's nothing wrong with that, right? Fiber channel is enhanced to FC NVMe, and it will deliver the value of NVMe over trusted fiber channel. If you are more, if you have use cases that are longer distance, remote replication, not that latency sensitive, you have a mix of legacy servers, or if you have the skills, you don't have the skill set to manage a lossless network that Rocky V2 requires, TCP is a great choice. So don't just get bogged down by simple performance metrics. Look at what you as a company is comfortable with, what your applications are, and what your existing investments are in terms of infrastructure, and then make the right choice considering all of these together. That is what is the Marvell and my recommendation. Okay, with that, it is back to you, Mike, passing control.
Perfect. Thanks, guys. Great discussion. I think we probably knocked off some of the use cases here, but we'll jump into it. I guess try it since we're running a little behind. If you guys just want to add to anything that was discussed in your 2 minutes of answering the question, that'd be great. So the first question is, what are the use cases for NVMe over TCP, and what strengths does NVMe over TCP bring to these use cases vis-a-vis other NVMe over Fabric protocols? And we'll start with you, Rob.
Sure. Thank you. So first of all, I'd like to defend Rocky for a minute. It seems like we had a little Rocky bashing session going on there. And I understand that, or I want to say, first of all, that of the competitors of ours on the phone here, all the ones that are billion-dollar companies, all of them have added Rocky to their portfolios in the last few years. So that tells you something. Secondly, Gartner, who recommends technologies to enterprise, are recommending Rocky be thought of as something that their customers should be putting into their systems for one particular application, NVMe over Fabrics. And then finally, I would say that besides Microsoft, which is widely known in Azure to use Rocky, also Baidu and Alibaba are now publicly saying they're using Rocky in their data centers. And one should think that these data centers, anybody who's called on the hyperscalers knows they're very secretive. So one might draw from that since 3 out of the 8 or so hyperscalers are using Rocky, that it may be used elsewhere as well. So then to the question, I would say that legacy connectivity is a great application, distance, as I said, management. And then I agree, if it's good enough performance, You can use NVMe over TCP if your application doesn't require the best performance. But keep in mind, you don't know what your next application is going to be. So, since it's no different, an adapter supports almost all the adapters of the people on this call support both Rocky and NVMe over TCP. You might as well make sure you're ready to implement Rocky over NVMe for when you need it.
Excellent. Tom, what would you like to add to the discussion?
I go back to the disaggregated storage, and the reason, I always showcase three: your traditional SAN, your hyperconverged infrastructure, and disaggregated storage seem to be three of the most common, let's say, configurations. And, as I mentioned, we've got customers, big and small, across enterprise, telco, cloud, that are all moving towards this disaggregated solution. So being able to take clusters of compute and connect them to, via TCP or whatever the other is. Of course, going back to the whole Rocky discussion, if you want to provision your whole infrastructure for Rocky, you got to pay for it. And so that's generally when I get pushback from customers, that's where it comes from. It's the cost of installing it, all the equipment that has to support it, the cost of maintaining it versus straight TCP. And so that's, I'm not going to, say that Rob is incorrect or anything, and that there aren't customers that aren't using it. But we see plenty of demand for TCP. That's what we're seeing. That's what we're really good at. Very similar to what Nishant spoke about and Elliot spoke about with acceleration. We also have acceleration. We've got benchmarks that show that we're very performant. So, but on use cases, I'd say disaggregated storage is going to be the runaway.
Excellent, Tom. Thanks. Elliot, what is Broadcom seeing on your side?
Sure. So again, I think a big thing for fabrics in general is storage disaggregation. And we absolutely see use cases for both. I mean, we are a big supporter of Rocky. We have that embedded in all of our technology, and we also are supportive of TCP. Again, any protocol that helps build the business case and helps with the adoption of the technology. That being said, one interesting use case for TCP/IP, more on the enterprise side, is iSCSI. I don't think we've really talked too much about that, but it's a 20-year-old technology at this point. TCP, NVMe over TCP is kind of a low-hanging fruit for that technology to significantly improve the performance of an existing Ethernet-based architecture. So that's one of the areas we see TCP or NVMe over TCP being a good solution for. And then again, we actually see, I think maybe Rob was pointing this out. I mean, there's multiple applications. There's lots of the cloud guys today, the hyperscalers who are doing Rocky, also doing TCP. Matter of fact, there could be instances where you need high performance within a rack and you want to leverage Rocky for that, but then you want to have more ubiquitous deployment across geographic scale and you want to use TCP. So there's going to be environments where we also believe that there'll be a kind of a mixed adoption of TCP and Rocky, and that's why supporting both is extremely important.
Excellent. And Nishant, what are you guys seeing at Marvell? Anything else you want to add to the discussion we already had?
I think, Mike, we covered kind of all the use cases. Everybody here is supportive of the technology. I feel that for disaggregated storage, the front-end connectivity by which clients connect to a NVMe all-flash array, TCP serves almost all the use cases for customers. One exception is certainly the people who are looking for that last ounce of latency. But it's important to kind of break down the all-flash array itself, which generally comprises of a controller node and many other kind of shelves of NVMe. And that is a more kind of controlled environment where the network is guaranteed, more closely tuned, and the Rocky challenges of congestion are less visible there. For that backend fabric, which is generally just in the hands of the people designing the all-flash arrays, RDMA protocol is a good choice. there. But front-end fabrics, I think TCP is a no-brainer. To me and the customers I talk to, simplicity wins every day.
Thank you. Thank you very much. Let's go to the first audience survey question. And so since we're running a little behind, I'm going to actually let you guys do the polling and answer the question while we go to the next participant question, or panel question, I should say. So just go ahead, go into the application, into the Zoom, and answer the question, and then at the end we'll put all the results into the slides. So with that, let's go to question number 2. How important are NVMe over TCP's advantages and disadvantages for its use case in real-world deployment scenarios? And I want to really push on the real-world piece of that. We'll start with you, Tom.
Well, I would say we covered it. It's the simplicity and ubiquity. There's not much more to say than that. You know, having the ability to have any infrastructure run this technology, that's what we're seeing. That's what customers are telling us. I'll tell you too, we're working with a lot of software stack companies doing interoperability testing, getting integrated into their stacks. And, you know, a lot of them, they've had Rocky for 2 years and they struggle selling it. And they say that TCP is what the customers are asking for. So that's what I'm seeing out there.
Thank you. Elliot, what are you guys hearing? I know you're talk to customers about both protocols, so I'm sure you've got some views on this too.
Sure. Again, I think we've covered some of this, but again, I agree with Tom that the TCP is a technology that's used across the network today. So really, it's the at-scale stuff that we see as kind of the main, at least initial reason why there would be advantages to leverage that and leverage the existing infrastructure. It's really going to come down to the architecture for each deployment. And so, you can look at, specific things like for Rocky, where like high performance data analytics, et cetera, that require the lowest latency and highest performance. Those are really compelling reasons to use Rocky. But for some of the at-scale cloud guys, performance may be sufficient for TCP for a lot of their applications. So again, it's going to come down to specific instances and use cases.
Very good. And Nishant, what do you see?
Sure, Mike. I think the advantages of NVMe over TCP, enough has been said on this call about it. Disadvantages beyond just kind of slightly higher latency versus other protocols. It's important for somebody deploying NVMe over TCP to understand that NVMe over TCP for most other solutions is a software onloaded thing where the server does all the work for that. So understand your pros and cons, whether you have the x86 cycles to invest in sending TCP PDUs out on the frame. If you have room for that, adopt a software solution. If you want your applications and you want to preserve your server cycle, choose an offloaded solution. One option is to use a Marvell FastLink solution. I think Tom talked about some offloads there too with SolarFare. So just keep that in mind. That's my recommendation.
Thank you. And Rob, any last words from you guys on this one?
Yeah, sure. So first of all the applications that we talked about that are good for, that I talked about that are good for NVMe TCP, it has its advantages that I discussed. One thing about rack scale technology is remember that technology, sometimes called compute storage disaggregation, is about disconnecting the compute and the storage, putting the compute or the storage in the rack independent of the compute node, so you can get better density, better utilization of the storage, all the things SANs were invented for years ago, nothing new there. But what's important to understand there is that latency, and especially tail latency, are very important factors to consider, because you're now putting applications that are used to local storage, meaning storage that has none of those effects, now is accessing it across a network. So if you have too much latency, your application is probably going to at least have delays, if not more significant problems. So I see that as a rack scale with NVMe over TCP is something you have to be very careful of the applications you're going to run on if you're going to use NVMe over TCP versus, NVMe over Rocky.
Excellent point. I think comparing it to where you're coming from to where you're going is important for any technology transition, and this certainly isn't any different than that. So that's a really good point. Jumping audience survey number 2. Now this one's a little interesting because it's a multi-part. There's multiple questions. So all you have to do is just check one of the boxes as the poll launches. You should be able to see that now. We'll give you guys a little time to go ahead and answer that. And with that, we'll move on to the third question for the panel. And that is, to what extent will NVMe over TCP replace other Ethernet-based NVMe over Fabric protocols? And how long will it take to do so? And we'll start with you, Elliot, from Broadcom.
Sure, thanks, Mike. Well, I guess that's the $64,000 question here. As I pointed out before, in the areas where there's real significant advantage, and I look at the iSCSI market as being one where NVMe over TCP will provide a significant performance boost and latency boost over the existing market. It's a market that's kind of, I guess, seen its prime, maybe the best way to put it. So we definitely see that market as kind of the first one that would be a good target for replacement. But how long all of these things take? I mean, storage is in general a slow-moving market. It takes a while to get adoption, and those technologies can last a long time. So, there's already been a lot of work done with Rocky. So we do still see Rocky as being kind of a driver in the market for fabrics, as well as fiber channel as well for the part of the market that's very fiber channel specific. And we see over time that TCP, because of all the reasons we've been talking about, will eventually start taking market share. Where things end up in the end, I don't have my crystal ball today, but I see again, or we see in general, that all three of them will have a play.
Thank you, Elliot and Nishan. What are your guys' view on that one?
So, Mike, the way I look at it, right, if you talk about, to what extent TCP will replace other protocols, replacing means there is the existing massive install base. But to me, NVMe over Fabric as a technology is relatively new. There's a lot of talk on NVMe over Rocky, but I don't think there is a point to replacement of something that is already established. My personal view is that there will be a lot of fiber channel and FC NVMe in the near future. There's customers who trust fiber channel, right? Similar to how Elliot said, and FC NVMe will help them accelerate their applications by scaling out NVMe all across the data centers. And after that, I think for customers who prefer Ethernet, TCP is a great choice.
Excellent. Rob, what's your view on this one?
Well, I think that NVMe over iWarp is probably in a little trouble because NVMe over TCP and NVMe over iWarp, not much difference, right? So I think that could be a version of NVMe over Fabrics that has some trouble with this. As far as Rocky goes, I think everyone knows my position on that. And as far as fiber channel goes, NVMe over fiber channel, I think that's in trouble for other reasons, mainly because there's no fiber channel in the cloud and all the growth is in the cloud and all the innovation that's coming in storage is coming out of cloud and moving into enterprise like scale out, hyperconverged, et cetera. So, over time, I think it ends up with what happened with parallel SCSI and SAS in a long term, but for now, I think Rocky and NVMe over TCP and InfiniBand, because of the supercomputer and artificial intelligent machine learning sort of things, will go on for the foreseeable future.
Excellent. And Tom, what's your guys' view on this question?
Yeah, I'm actually going to play a little bit off Nishant and Rob on that one. So Nishant's comment about, when you talk about replacing something that barely exists, NVMe OF is a new technology, period, no matter what transport it's on. But one thing I think you see more of, if you've got an infrastructure of InfiniBand, if you have an infrastructure, a fiber channel, they're going to use that. They're not going to change that, and that's a traditional SAN market. If you're talking about what Rob was talking about, which is the new cloud deployments, that a lot of the cloud folks that I've spoken with, they've been looking for this disaggregated storage solution, and iSCSI was not optimal. It was too slow, right? It's orders of magnitude slower, not tens of microseconds. It's orders of magnitude slower. Fiber channel wasn't a play due to cost and everything else. It was a cloud environment. So I think it's less about when TCP takes over some of these other protocols, and it's more when the advent of a ubiquitous technology makes it cost effective and simple enough that this disaggregated storage application is going to take over the SAN. And I think if you have a SAN, you're going to keep it. If you're building new infrastructure, you're going to go this new way. And just SSDs at all, compared to spinning hard drives, have created this opportunity. And any of these NVMe OF over Fabric transports are going to take advantage of that. It's opening up that new opportunity.
Yeah, I think that's a really good point. I mean, let's face it, 5-6 years ago, we were barely hearing about all flash arrays, and so things are going fast, and sometimes it's hard for us on the edge of things to realize that we're way ahead of where everybody else in the industry is, or where users are. So with that, let me jump to the third audience survey question. If you guys can go ahead and answer this one, and we'll give you a couple of minutes, and then we'll jump into the Q&A and wrap up the webinar. We'll let the voting go on for another 30 seconds. Let me read the first Q&A question. This is from Rick Brown. We'll go through the panel. We'll start with you, Rob, on this one, and then we'll go through just as you guys see it. If you want to add something, feel free to jump in. But his question is, what can be done in legacy TCP IP networks to reduce lossiness and mitigate congestion?
This is for NVMe over TCP or Rocky or what?
My assumption is it's for NVMe over TCP, I would assume.
Okay. Yeah, so there's many well-known mechanisms in TCP IP networks for doing work, getting rid of congestion or at least mitigating it, and many of them are the same things that Rocky uses. So priority flow control would be one, and the PFC would be another one. Those are the two that jump to mind from me.
Excellent. Tom or Nishant or Elliot, do you guys want to add anything to it?
And just one thing I will say, Mike, when regards to kind of congestion for NVMe or TCP, if anybody who understands TCP knows TCP is an aggressive kind of protocol, and it is possible that switch buffers might fill up, causing lost packets and retransmissions and things like that. And that is why newer TCP stacks, especially DC-TCP as well as kind of ECN-related protocols, kind of help manage this situation a little better rather than TCP responding only after slowing down only after drop packets. It kind of helps control the buffer utilization on the switches better so that TCP does not end up in those situations. So I would recommend for somebody who has low tolerance for congestion or latency on TCP to utilize DC-TCP as their TCP stack with ECN.
Excellent. Tom or Elliot, do you guys have anything to add to this?
I'm good.
I think, the comments that some of the folks have made already are pretty relevant. And again, there's various versions of TCP and congestion control that are out there I mentioned earlier.
Excellent. Thank you very much. All right,
Mike, I answered somebody's question online, and I don't know if you got bumped or not. Jerome Went.
Yeah.
Yeah.
Let me see if I can pop up on the answer side. So, yeah, so Jerome asked, you compared NVMe over TCP performance to Rocky and RDMA, but since NVMe is intended for general purpose use, isn't it more appropriate to compare it to iSCSI? How, in that scenario, iSCSI versus NVMe over TCP, how do the two compare? Tom, why don't you go ahead and answer that one first, and then we'll go through the rest of the group.
Yeah, so if you look at traditional iSCSI, we've got SCSI commands. SCSI is way heavier than NVMe. So some of the early iSCSI solutions that were used with SSDs, what they would do is take the NVMe command or request, and they'd map it into SCSI, and then map the SCSI into iSCSI, and then transport it. Some of the benchmarks we had, it's orders of magnitude. It's not even in the same ballpark. It wouldn't even show up on the grid of any of the benchmarks that all of us showed in this presentation. So in that sense, going from an iSCSI solution to any of these transports is going to be a huge increase in performance, orders of magnitude.
Excellent. Nishant or Elliot or Rob, do you want to jump in on this one as well?
I would just add, this is Rob, I would just add that if you look at the article that's in one of my slides from the Pavilion example of legacy support, they actually did a comparison of NVMe over TCP versus iSCSI at a data center scale level. So if I'm working off of memory, but I think the latency number for iSCSI was 400 microseconds, and for NVMe over TCP was 200. So that gives you at least a feel.
Excellent. Elliot, Nishant, do you guys have anything to add to that one?
Nope, Mike, I think we covered it.
Yeah, me neither.
Okay. Next question, how do we compare between TCP and iWarp? And again, I think this is NVMe TCP versus NVMe iWarp.
So I'll take that, Mike. Since we support iWarp as RDMA protocol. One thing to understand is that RDMA protocols like Rocky or iWarp have many use cases. One of them is NVMe over Fabrics, and NVMe over Rocky and NVMe over iWarp, and similar is NVMe over TCP, right? Both iWarp as well as TCP do not require you to provide a lossless network, manage congestion better, and things like that, as we compared that with Rocky in our discussion earlier. But beyond NVMe over Fabrics, iWarp has many other use cases. Take hyperconverged storage, for example, like Microsoft Storage Spaces Direct, and Microsoft recommends iWarp for Storage Spaces Direct as the RDMA protocol. So when you think RDMA, think beyond NVMe over Fabrics. There are other use cases too where iWarp fits in very well.
Thank you. Rob, Tom, do you guys have anything to throw in on this one?
The only thing I would
Not
add
for
is
me.
that Microsoft Spaces also has, recommends support for NVMe. I'm sorry, for Rocky for their cluster interconnect as well.
Absolutely. All right, let's jump to the next question. This one, I'm going to go to one by Jonathan Hinkle, and that is, as NVMe TCP gains adoption maybe over the next few years, what percentage use do you expect to be within the rack versus outside the rack or outside the data center? We'll go ahead and start with you, Elliot, if you want to jump in on this one.
Sure. Well, it's always hard to throw a percentage at these things, but I think to some of the points I think all of us were making earlier. I mean, what we're seeing today, at least, is within the rack where latency and performance is is very important, that we actually see Rocky as being, pretty important there. Now there's always going to be use cases, and there's certain hyperscalers today who are TCP only, but for others, especially if you're looking at things like in-memory databases, things like that, performance is going to be paramount. And so we see Rocky as kind of more of the in the rack solution, and potentially even, again, as it depends on the operators, but even within the data center. Certainly across data centers, TCP is a more likely candidate for distribution. But again, it'll be hard to tell. It's probably going to be, dependent on the operator themselves.
Excellent. Tom, do you have an opinion on this one?
I would think, within a rack or a row is where you're going to see the adoption the most. So I don't think you're going to see it, over a network per se. But the whole idea of the disaggregation is, I'm going to make a bunch of cheap servers and I'm going to separate the compute from the storage, and then I've just got this lake of storage. So that they could easily implement that in the rack. I would think that's where you go first. I don't know that people are going to overcomplicate it.
Excellent. Rob, what is your guys' view from Mellanox's perspective on this one?
I think there's a couple of things. One is that a lot of storage applications, and granted this is early in NVMe over Fabrics, but a lot of storage applications use distance for high availability and disaster recovery. So I think NVMe over TCP has a really good place there, because why do protocol translations if you don't have to? And then secondly, I would add that outside of the rack, hyperscalers are proving that Rocky technology in general works at the data center level, the data center scale level. So I don't think there's any difference there, other than once you go out of the data center, I think you need to use NVMe over TCP, or if you're not focused on the performance perspective.
Excellent. Nishat, do you want to add anything to this question?
Just one quick thing for the audience. I think what I ask is kind of look beyond use cases, whether it is using TCP within the rack for remote replication, disaster recovery, and things like it. Think beyond use cases. Think what technology you are comfortable with. What is your skill set? I'm reiterating this. Don't just let performance bog you down, or just use case bog you down. And end of the day, the solution that will be successful in your data centers is the solution that you are most comfortable with. If it is fiber channel, so be it. If it is TCP, so be it.
Excellent. And I think we have time for one more question. I apologize to those people whose questions we didn't get to. I'm going to hit this one from, let's see, it is, I'll let Rob answer this one first. I thought Rocky with modern RNICs no longer requires a lossless network.
Yeah, so like TCP over the years continued to improve its capabilities. Rocky, which actually uses the transport layer from InfiniBand, which was a lossless network like Fiber Channel, so it didn't need a lot of the mechanisms a transport layer needs in a complicated network like a data center. That transport layer in Rocky has been continuing to get improved. Now, it isn't changing the standard any, so the protocol on the wire doesn't change, but that transport layer's software or hardware or combination of is just getting better and better and better with, at least from our company, every generation of our products, it's better. Again, totally interoperable with all Rocky in the past. It's just that transport layer gets better. And that, I think what the question is asking is, they've probably heard or seen, in fact, that each generation of our adapters and even firmware updates on existing adapters are getting better and better at handling lossy networks. And in fact, not to pre-announce anything, but I think you could think in the future, Rocky can probably, with the right, transport layer capabilities, run in a lossy network, probably even better than TCP/IP, because it's been designed after it and it's been focused on congestion, dealing with congestion.
Excellent. Thank you very much. Well, with that, guys, let's go ahead and wrap up the webinar. A couple quick notes. We will send out a link to all registrants for the recording and for the slides. That'll happen in the next couple days. Other than that, thank you for your time, and thank you to the panelists for being a part of this webinar. Hopefully everybody got something good out of it, and have a great day.